Okay, salam and good day to everyone. So in this chapter, we are going to proceed with the syntax for the program control. So this is when you start to work on your program, you need to know how to manage the program itself. I mean, how the flow will looks like. And this syntax for the program control is going to be used to control where you are going to run or execute your lines. So before this, when we do all the examples, it's very straightforward examples. It's actually one lines down, means that you can start from the top and then you can finish at the end of the programming. But in here, for the case of the programming, you need to understand how to control your execution lines and where you want to go. As for example, that when you have the subroutines, you have something to do something else outside from your main program, then you should know how to work on that. Okay, so this is the flowchart symbol. If you can go back to the C++ last time, this is a common flowchart symbol where you know that when you want to work on any algorithm or any software or any codes, any program, you must know the algorithm first. You must know how it will flows. You must know how to draw the flowchart of the system or the algorithm. So here you can see that we have the diamond shape over here. You have the quite eclipse over here. This is related to the start end, and you can have all the connectors here. This is about the decisions have to be made, and this is about process. And this square box with this one, we have the subroutine, and this is related to the input output. So each of the types of shapes is basically representing something. So remember that you have you must know how to write this flowchart when you want to write a program. That's all. Okay. Next one is the this is another one. This is continuity from the first one just now. So when you have the conditions, you can know that this is like the if-else statement. Okay, this is just like the if-else statement, and this is about the looping. Right, this is about looping, something like that. So this is also checking and loop, and this is the one that we always use most of the time last time in the class, where I just execute this one, then we have this one starts with and at the end at the codings over here. So this is a algorithm flowchart. You must know how to work on that. So if you know how to draw this one, right, then you should know that how you can program your codes to go here or to go here somewhere, because most of the time we are using this one. Okay, in this program control instructions, right, we can divide it up to 5 types of control instructions. One, they call it conditional branch over here. Conditional branch means it will jump a branch with a conditions, which means that you are going to check something before it jumps. And then you have the unconditional branch. Okay, this is no need to check anything, but you are forcing your code to branch or to jump somewhere else. Same goes to jump. Jump is related just jump to anywhere that you want, sort of like conditional, but it is related to jump. Okay, next one, it has a subroutine call, where you can call a subroutine, and then it can go to the subroutine and execute the subroutine and can come back. And the last one is about to return back to the program. Okay, so there are 5 types of program control instructions over here. The example of program control that you can use in your program later is all about this one, but we are not going to use most of them, so I'm going to teach you a few of them so you can see the example of the program, how it works, and then you can try to look at on the other codes syntax, and you can apply it later. Okay, for this program control instructions, right, this is about the mathematics on the how it jumps from here to here, from here to the other branch, to the other label, something like that. So this is later about the how many displacement that it can go. To make it easier, okay, for example, for the is unconditional branch over here. Okay, what does it mean here? The BRA means is going to branch always. Okay, it will going to branch no matter what happened. It's going to go to the label that you are assigned it for it. Then it will not going to wait or check any conditions from the flag. So that's why they call it unconditional. And the syntax is normally like this: is branch to something. Okay, so this is all the spec or the parameter, the condition codes, all this related about. So I'm going to show you how it works over here. So let's go to your Easy68K. Okay, so let's try to do a new one. Okay, I can just write down like this. Okay, move.long anything hash $sign AA to D1, and then I can do move.$long hash $sign BB to D2, and then I have another one move.L hash $sign so CC to D3. Okay, this is a normal one that we have been using for the past lectures. So you can compile this one, and then you can execute it, and then you can run it line by line here, one, and you can see that it goes down, then it goes down, and it's finished. It does not move anywhere. So this is N, because you are not assigning anything. So let's try to assign a branch. So you can close this one, try again. Branch to where? So here in the code, it says that branch to any labels. So remember that label you can put somewhere here at the first row in your code. For example, I can just use the branch here. I just want to cat. Okay, just put cat. It's a name, just a name. Okay, so I'm going to put branch cat. So what happened here? So if you run it one by one, at this particular branch cat, you'll go to the cat again. It was not N because that is the branch cat. Okay, so you can see that the point counter. Okay, point counter, you know that the functions of point counter is the address where you want to execute it. For example, this branch cat is at 1012, so this is 1012. So it means that right now you're going to execute this line, the point counter. So what happened after that? When I hit this button, it changed back to 1000 because it had moved to 1000 locations again. So the point counter is the address that you want to execute. Okay, so that's why in this one just now, this instruction affects the processor point counter by offset value. So when you jump, it must know this offset. Then it will finally can go to the branch. So this is related to this one. Okay, so this is the displacement. This is the offset. It's calculated automatically by the PC, by the CPU, right? So example here, you have this command. This is the same one just now, like a branch over here. I can try to need to run it over there. So you just have this code you can run by yourself in Easy68K. The formula is very simple. How to calculate the offset? You must know the target address. Target address is the branch, okay, the branch address where you have the label there, and then you minus the current PC. The current point counter, okay, is must have the instruction branch always address plus 2. Okay, so this is the formula. So let's look at the command here. So this is a command just now. It nearly the same like this. Right, you can know that this is the line, this is the address. So in this example, this is the line, this is the address. From the instruction branch address, this is branch address. Branch always you have to go to where this is the one, right? So this is the branch address. The branch address is this one, 1000. Okay, then the target address, this is branch last. So where's the last label? Last label is over here. Look at the address here. So it's going to be 1006. So the formula for the offset is going to be 1006, which is your target address, minus the program counter for the branch plus 2 in hexa, and this is going to be your offset. So this offset, this is the one, so means that the latest program counter must have the offset because it's going to branch jump, not one by one, right? For normal process, it's going to be one by one. So this is because of you have the branch always, you have to jump. Okay, you can see that this is actually a positive number, so you know that this is going to be a jump down here. Okay, just like a positive number. So if you go to the second example, this is, you can see that the branch is at the bottom of the program, and your branch Muller is over here. So this is the target address. So you can see that target address is 1000 because of the locations is here, and then the instruction for the branch address is at 1006. Then you're putting back the formula for the offset. You can see that this is a sort of a negative number because of the branch is actually at the bottom of the program. So you can see that this is the case. Okay, so this is for the 8-bit sign displacement. This is very small displacement. So for the next example, it's about 16-bit because this is related to a very big jump for a very big branch. You can see the example here. So you can see that this is quite a long program, but it is shorted in the slides. So run. The example for the instruction branch address is at 7000. Branch is over here at 7000, and the Muller is over here. So you can imagine that this is quite a long jump from 2000 to 7000. So it's going to use a 16-bit sign displacement. Okay, so this is again from bottom to the top. Then you're going to have a negative, sort of a negative offset over here. Okay, for the case of branch just now, means that you should understand. It's very simple. The branch will always go to anywhere. So it means that if I change this one again to another example, okay, let me try to have this one, not cat here. I have the second line's cat over here, and then you can run over here and then execute it. Let's look where's the cat's going. So it's not going to the first line from previous example because the label of the cat is over here. So you can see that this is a false branch. You do not check anything. Okay, so same goes to jump. Jump is quite similar. You see that jump is effective address to or to that label. I can change the branch always to jump. JMP. Okay, let's move this one. Okay, let's run again. So it's jumping over there, jumping to the label. If I move this cat again at the first line, so jump to that cat. So it's moved back to the first line because the label for the cat is at the first line. Okay, this is more or less like the same with a branch always. Okay, let's move on. Next one is a conditional branch. So this is different. Conditional branch is a branch performed in a program according to flags of condition code register CCR. So remember that there's a one chapter that we learned about the CCR codes, where you have to know what is the flags. There are 5 flags that we have. We have the C. We have C, hold on, we have the C flag, we have the V, we have the N, we have the Z0, and we have the last one is should be carry a negative. I forgot about the last one. Okay, but it's okay. XCVN, it's okay, doesn't matter. All right. So this flag, okay, is always being changed accordingly to the syntax that you execute. So based on this, right, so this conditional branch will look at this value. For example, they will look about only at Z flag over here. Based on the Z flag, then it can make decisions whether to jump or to stay. Okay, the purpose of the conditional branch is to transfer control to a new location in the program depending on a certain condition. That's why they call it a condition, because you need to check whether maybe z is equal to 1 or 0. One example, they call it BCC. This is a label over here. So in this BCC, what is the flag is tested? This is where let me check where the size. Okay, the BCC is checking the C flag over here. So this example, in this BCC, it will check the C flag. Okay, I'm not going to touch to have this example, because I have another example that which is very similar to this. Okay, so we have a table over here. We are not going to touch everything. The one that I'm going to touch is these two things. They call it BNE and BEQ. So this syntax, okay, this syntax is going to check the Z flag. Okay, for example, in this Z flag, what does it do? It will branch. It will branch if not equal. When the condition of Z is equal to 0, it will branch. If Z is equivalent to 1, then it will not branch anymore. It will go down. Same goes to this one. This is a opposite of it. Okay, that's the branch happen. So let's look at the example how the branch look like. So before we go to the example, this is another table that's using all the flags, because you have lots of syntax. So we have BVS, we have BPL, we have BMI. So all of these are being used in the program control. Okay, let's look at example here, how the BNE works. So let's run your Easy68K again. Okay, I'm going to write down a code over here. Okay, just a quick one over here, because I have a copy of it. Okay, I'm having code over here. This is what they call it, sort of doing a delay, but doesn't matter at the moment. You just need to know how it works. Okay, before that, I'm going to have a code at the beginning of the codes over here. So you have to run it at your system. You can then you can see it, right? So okay, here. Okay, doesn't matter here. So we have the first line. Okay, I don't want to use return to subroutine yet. Okay, this is the command. Okay, if you remove out this the label here, this is just a normal command that we used before. Now we have this BNE. Okay, here, okay. Let me write another one. This is moved along any kinds of syntax. An example here I can try. $AA to D0. All right. So let's run this code. Okay, how it works. If you go to this particular code, right? So I'm going to run 111. So you can see that this program counter is putting at 1000. So you have to execute this one first. So this one go in, then move on, then BNE, then you go back there, del 1, 2, 3, then you go down. Then does not move, end already. This is the end. So I'm going to push back to the loop, so I can just write down another one, JMP to loop. Okay. So run this one by one again. So it's going over there. Now going down, jump loop, then you go up again. So this is consider a continuous loop. But how it works on BNE? Let me show you the progress. Okay, now this is the first one. This is not really a big important one. So let's look at this command. Okay, I'm going to write down here. Okay. Okay, what does it mean? Here, move dot long, okay, 3 to D6. Then this command is to sub that particular D6 over here from 1. This one is checking the Z flag. If the Z flag is still equivalent to 0, it will jump to this one, del 1. Do it again until the contents of D6 is equivalent to 0. Then your Z flag is going to be 1. Then it will exit the branch and going down. Okay, let's look at how it works. Okay, the first one, when this one is moved to D6, your first D6 is going to be 3. Once you minus out, right, when you minus 1, D6 minus 1, then your D6 is going to be 2. Your Z flag is still equivalent to 0 because this is not a 0. This one, when the BNE see the Z flag is equivalent to 0, it will jump to this branch. That's why it will go here, BNE, and then go to del 1. This is the label of del 1. Go back to here and redo the same process again. Now your D6 is minus 2. 2 minus 1, sorry, equivalent to 1. Your Z flag still equivalent to 0. Then what happened is the BNE still checking the Z flag. BNE still checking the Z flag. Then it still jump to del 1. It will jump again to that one. And then the last one, D6 is equivalent to 1 minus 1 because this operation is being used again. Okay, now your D6 is going to be 0. Z flag now changed to 1 because the contents now is 0. Z is equivalent to 1. Now this BNE is checking the Z condition. If Z is equal to 0, you go to this one. But now it says Z is already equivalent to 1. It will not go to this particular label again. It will go down. Same goes to this one. Okay, let's look at how it works in Easy68K. I'm going to compile this one. Okay, one by one. So now you can look at delay move.long 3 to D6. D6 now is 3. Then you're going to subtract 1 from D6. Now is 2. Z flag is still equivalent to 0. BNE checking the Z flag. If the Z flag is still equivalent to 0, it will jump to del 1. Go back to del 1. Then this command is again to subtract the contents of D6, which is 2. Now it's 1. Still your Z flag is equivalent to 0. It will go back again to del 1. Here, right? Now this command again is going to subtract 1 from 1. Is going to be 0. Your Z flag now had been changed from 0 to 1. BNE say that if I see Z is equivalent to 1, I'm not going to do this one anymore. I'm not going to branch to this one anymore. I'm going to go down. That's why it's moving down. Then this one just a move command. Go to jump to the loop. Then it will go to this loop. So you need to understand from this case, right? For the BNE, it will check the condition of the Z flag. If the Z flag is still equivalent to 0, it will branch to that particular label. But the BEQ is opposite. It will check if the Z is equivalent to 1, then it will jump to the particular label. So that is the concept of branching. This is just like if-else statement, means that you are going to check this is correct or not. So if not, then you have to choose the other one. Okay, this is the example that you can play, and this is again about the BNE. You can play this one, it will move like that. Okay, it will move this one based on the again label over here, and it will finish the content of the minus up to Z is equal to 1, then it will move down. Okay, the rest over here is more on the pattern. If you look at the high level language last time for the C++, you have the if then statement. So this is how it works in assembly. So you can use BCC, something like where you want to go skip over here. So this is how about the test, then you choose a branch, sort of like this. This is the pattern. Same goes to the pattern. This is the one example here. You can see that from the if then statement, this is the example that you can play. Okay, you can this one, you check for the C flag here. If yes, then you are going to do this one. Else, no, you are going to add something like that. All right. Next one. Another pattern is about the if then else. This is about the if else statement. So this is the pattern looks like. Okay, then you have the BCC, then you have the branch exit. The example is like this. You can play also this one. Possibly that you have to use it in your programming in your PBL session. Then you have the do while test. Okay, do while statement. This is about the looping, something like you have to check and then keep on looping. Right, you have this loop. So this is all related to the C++ last time, but the C++ is using the syntax in high level, whereas in MicroP you are using in assembly language. Then this is another example from this particular do and while test. You can try, have a look this one. If you want to use it, you can put it in your program later in your PBL session. Then you have this while do test. This is an example for the for to do this one. This is about the common example that we have, and that's all for the normal syntax that we are going to use. Okay, other than that, this is about the example. You just can try on this example, and most of the important thing that I want to touch on this particular slides is we need to know the differences between the jump to subroutine or branch to subroutine versus jump to branch. So again, you can see that jump to subroutine is another thing to jump to the subroutine, and jump, this is more like an unconditional one, and same goes to branch always. Okay, you can see that both jump to subroutine and BSR, okay, back I'm not sure, I forgot, and jump to the branch always. Okay, this will jump to subroutine. However, there are differences in implementation. Okay, so both JSR or branch to subroutine, so this is jump to subroutine and branch to subroutine, will push the destination address to program counter, and the return address, okay, the return address, now you are learning about the return address. This is the return address, is going to be saved to the stack pointer. Okay, thus the return to subroutine instruction is needed, where the RTS will pop up the return address inside the stack and put it back into the program counter. Example that we are going to have on the jump to subroutine is this one. I have a code over here. Okay, you should try copy this one. This is more on like a blinking LED. So this is going to blink the LED on and off. you can see that this is a jump to subroutine. The routine name, subroutine name is delay. It will jump over here to delay, complete this one, and then after complete, this is going to be at the RTS. RTS means return to subroutine, which is going to return back to the next address at here instead of going here. So what does it mean? It will save. Once you jump to subroutine, it will save the address of the next one at the stack pointer, and once this one is called, it will go back to get the address at the stack pointer, put the program counter, and it will execute it. So how it works? Let's try to look at. So what does it mean of return address? Okay, now you can see that this is the command. The return address normally is saved at the stack pointer, which is at the back, at the last one in your memory. So this area. Okay, let's look at the process. So this is going to be put the value to the area of this location at the memory. Then move, jump to subroutine delay. It will jump to this delay. And then this is going to move down. Again, this is a command to subtract. Once the jump, actually now you can see that this is the address on the next execution. Okay, I'm going to run again this one. I forgot to show you that one just now. Okay. Okay, this is still empty. So the command right now, program counter is 1000. So I'm going to execute this one. Jump to subroutine. The command now is 1008. When you jump, the next address for this one is going to be saved at the stack area over here for temporary, because when this return to subroutine is being called, this value over here will be put back to the program counter to be executed. Okay, so jump to subroutine. Look at over here. Jump to subroutine. It will jump here, and then you can see now the address. This is they call it the return address. The address where you need to return. 100E is over here. So this command is going to be return. This is going to be going back after the subroutine is finished. Then we will go back to this one to execute it. So you can see that this one go here. Okay, go down. Now RTS. Once this one is being executed, the address that we saved just now is going to be put back to the program counter. That one. And then that's why they call it a return address. So we are going to push this one again. Now this is also a jump to subroutine, means that the address is going to be saved again to this one, which is this one, 101C. Look at this one here at your stack area. Now the address is changed to 101C because that is the return address once you complete this subroutine with the return to subroutine command over here. Now you can see that this command will take the address, go to program counter to be executed. See that one. Now this is branch loop, it will go out back. Okay. Here, what does it mean here? If you use a jump subroutine and branch subroutine, it must have the return address. This return address will be saved to the stack, and that is by pointing of the stack pointer. Okay. Thus, return to subroutine instruction is needed. Okay, that's why when you are using the sorry, not this one. When you are using a jump to subroutine or branch to subroutine, this command return to subroutine is a must, because without this one, your program going to be lost. It does not know where it's going to return. So return subroutine is a compulsory when you are using JSR or branch to subroutine. Okay, this is what the meaning of this statement. Okay, the jump and branch always will push the destination address to parent counter. However, no return address will be put to the stack. So once you use jump or branch, the stack area here just now is not going to be used to save the return address. Okay, thus RTS cannot be used, means that here RTS cannot be used if you use jump or branch always. Thus RTS cannot be used with jump and branch always, since there is no return address inside the stack. So you must know which one and which one need to be used when you want to jump or you want to branch somewhere else. Okay, so that's for the program control for the lecture. We are going to work on the example later. Hopefully you guys understand on this one. Thank you very much.